Most people think manufacturing processes, casting, machining, and welding are just workshop skills meant for technicians. But the truth is that these processes exist because every engineered product must physically be made, not just designed on paper. Long before engineering degrees existed, humans were already casting metal, shaping parts, and joining materials to solve survival and production problems. To see this clearly, imagine a simple, everyday situation where you use a metal spoon. That spoon wasn't carved out of solid metal randomly. It was formed using a controlled manufacturing process. At some point, molten metal may have been poured into a mold, casting, excess material may have been removed to get the exact shape, machining, and different parts may have been joined permanently, welding. Without realizing it, you're holding the result of multiple manufacturing decisions in your hand. What's actually happening here is simple. Manufacturing processes control shape, strength, surface quality, and cost. Casting allows complex shapes to be formed efficiently, machining provides precision and tight tolerances, and welding joins components into a single functional structure. Each process has advantages, limitations, and failure risks. Choosing the wrong one can make a product weak, expensive, or unreliable. This same logic operates at an industrial scale. Engine blocks are cast, shafts and gears are machined, and bridges, pipelines, and vehicle frames are welded. Engineers don't choose processes randomly. They select them based on material behavior, load requirements, production volume, and safety. A perfectly designed part can still fail if it's manufactured poorly. The systematic development of modern manufacturing was accelerated by pioneers like Henry Bessemer, whose innovations made large-scale metal production affordable and consistent. This shift transformed manufacturing from craftsmanship into an engineering-driven, repeatable process, laying the foundation for modern industry. Now that you understand the intuition behind casting, machining, and welding, the next natural step is to explore manufacturing defects, tolerances, and quality control, where we learn how engineers detect, prevent, and design around real-world imperfections. And that's exactly what we'll break down in the next episode.